Lesson 1. Transformations of exponential and logarithmic functions. As you know, exponential functions are in the form y equals to b, which is the base to the power of x. If base is greater than 1, then it is increasing, and if the base is between 0 and 1, it is decreasing. Logarithmic functions are basically the inverse of an exponential functions in the form y equals to log b, which is still the base, and x, which are x values. The increasing exponential function will remain increasing, and the decreasing exponential function will remain decreasing. And you can check this by getting 2 points and drawing a line and checking the slope of that line. Transformations of exponential functions take the shape in y equals to a, which is vertical stretch / compression, to the power of the base k brackets x minus d and then plus c. And in this instance, k equals horizontal compression / stretch, d equals horizontal translation, and c equals vertical translation, which is also the horizontal asymptote. If a is greater than 1, it is a stretch. If a is less than 1, it's a compression. If k is greater than 1, it is a compression. And this is due to, because you have to flip it, so 2 equals to 1/2 once you flip it. And if k is less than 1, is a stretch, since you have to flip it again. So flipping 1/2, it will give you 2. D is equal to horizontal translation, so basically left and right. Vertical translation, up and down. Logarithmic functions translations are basically y equals to a log b brackets k brackets x minus d and then plus c. And it's the same thing here. So a equals to vertical stretch / compression. When a is greater than 1, it is stretch. When a is less than 1, it is compression. If k is greater than 1 is compression, and if k is less than 1 is stretch horizontally, and if d is basically the horizontal translation. And since in the exponential we had a horizontal asymptote, the inverse of an exponential function will have a vertical asymptote, and c is still the vertical translation. To graph a transformed function, exponential one will do first, is when graphing, you first should draw the base function. So the base function would be 10 to the power of x, since log b is basically log 10. So if we do y equals to 10, to the power of 0, y is equal to 1. If we do y is equal to 10 to the power of 1, y is equal to 10. And then let's take an example for a transformed one. So let's do y is equal to 3b brackets x minus 2. So as you can see that all of the y values will be multiplied by 3, and all of the x values will add 2. So let's do 0 plus 2, which is equal to 2, and then 1 plus 2, which is equal to 3, and then 1 times 3 is equal to 3, and then 10 times 3 is equal to 30. So basically you just get the points. Let's make this 0, and then you have 2, 4, 6, 8, and then when it is 2, you are 3, so 1, 2, 3. So when it's at 2, you have this, and then when it is 3, you have 30. So it would be somewhere over here, and then this is also basically just like this, going like this. Thanks for watching, and I hope this video was informative. And this was the lesson 1, transformations of exponential and logarithmic functions. Please stay tuned for more videos.